Hello, fellow problem solvers. So today we're going to be doing the problem from the 2024 IMO, problem number 4. This nice geometry tryout for at least 10 minutes, ideally 45 to maybe even 90 minutes, not more than 4.5 hours. Draw the diagram and put your first ideas out on paper for the next 5-10 minutes, and now let us begin. So what do we have here? Well, first thing you notice when you see a problem like this is that there's a lot of different things being defined, a lot of different points. And the first thing to do when you have so many definitions is draw the things one by one and then look at what is it that's sort of like added as an afterthought, what is like something that is really, how are you like drawing the problem is a important question to ask yourself here. So here, what do we have? We have a triangle ABC and we have that AB is the smallest, BC is the largest, okay? So, and we're going to have ICD in circle, in center, and we're going to have tangents to the in circle, okay? Some parallel lines that have some lines that are tangents to the in circle. We're going to have AI intersect the circle of ABC, okay? Midpoints of AB and AC. Okay, midpoints of AB and AC, these are sort of just an afterthought to get KIL. Y, PX, okay, P and X are defined with the circumcenter, not the circumcenter, with the in-center. So that's also another thing to note. We won't need to really add these points until later on. They might be used for some, I don't know, some similarity, some 90-degree angle, and like a hypotenuse type of thing, but we don't know that. So for now, let's think about how we're going to draw this. So what I'm going to first do is I'm going to draw a circle. So let's draw a circle with center here, center O. And now what do I know? I know BC needs to be, because it's the largest, it needs to be the closest one to this center. I know AI intersects the circumcircle at the midpoint of this arc. If this is B, C. I just need to draw A such that this is a bit further away. A is on this side. And now we have the triangle ABC. And now I know AI intersects this. Now, because of a lemma that I know how to draw AI. I just take my, what's it called, compass, and I do this. And here I get I. And these two are also the angle bisectors. Another thing to notice is that there's some symmetry with respect to B and C, how things are defined, and A is sort of the thing that you're defining things with. So that's why I put A on top. So this here is now P. Now let's look at these points X and Y. I mean, those are the primary points for us to look at. So we're going to have the in circle. We're going to draw it nice and slow. Okay. And now, okay, so we have line X and BC, different from C, X parallel to AC. So it's going to be this line over here that is parallel to AC. That will give us point X. And then Y is here parallel to, gives us Y. And in fact, I might even be making a mistake by drawing X and Y at the same time. And then K and L are just going to be the midpoints of AB and AC. We care that this angle plus XYP. Now XPY seems to be a difficult angle to think about. KIL is also difficult. But the first thing is first, let's calculate some angles. Let's see what is it that we have. So this is alpha half, beta half, gamma half. And now, let's see, what do we know? So this thing right here is parallel and tangent to the in circle. So this thing right here is gamma. Now, because it is a tangent, I also know that this is like, take a minute or two just to think about what you know given this thing right here is a tangent, and so is this. And the answer is, well, you know that XI bisects this angle over here. And you know that because, like, if you take the perpendiculars here at 90, you will get that you have two triangles which are congruent. So this thing right here is 90 minus gamma half, and this is 90 minus gamma half, these two angles. And now, what do we have? We have xic needs to be 90 because this is gamma half, 90 minus gamma half. And now, what do we have? Well, we have the definition of x and y without the in circle. Now that's also just important, just like take a second to think about this. We've now defined x and y, we know its characteristics, and we've done so without using the in circle. Like there's no need for this tangency condition. We know how to define this. So we have this is alpha half, this is alpha half, and these two angles are 90. And now let's think about what we need to prove. Because this is everything we really can find out about x and y. We could be adding new points here. And now we have also the midpoints of AB and AC. And now the question for you is, how can we connect this? So K is the midpoint of AC, KIL. So how can we connect KIA to something with x, y, p, right? Or I, or B, C, any other point. And there's really two ways to think about this. One way to think about it is, okay, I have basically a lot of angles here. I have P as the center of this circle. And now let me see if I can create, so K is a midpoint. I'm not going to get this angle just by anything. Like I don't know what this angle is in terms of alpha, beta, gamma. But maybe I can, use some similarities. So two triangles with alpha half and gamma half. Like that's nice. And then I take this midpoint and then I know what that angle is. So for example, I know that this angle right here is alpha half because the whole thing is a 90 plus alpha half. So this is 90, this is alpha half. Now I can say, okay, what if I take the midpoint here? And then I will get, okay, that this angle is equal to this one if I take the midpoint. Interesting, but not quite giving us anything that we can use at this moment. So our question is, okay, what else is there? Well, let's think about this is adding a midpoint. And also things like, can we make something a midpoint? And here it takes some level of thinking ingenuity to see like, okay, we have alpha half, we have these 90-degree angles. If I extend this to meet say the circumcircle of BIC at point B prime, I know because this is 90, I know that B prime P and B are collinear. And I also know that this angle here is gamma half because it's the angle on the chord BI. And now what do I have? I have gamma half, I have alpha half, and I have P as the midpoint. And I have gamma, no, not gamma, but Y as the angle. So I have the triangle B, Y, B prime, which is alpha half, is similar to A, I, C. So now we take the midpoint K. And what do we get there? We get that the angle, we get actually the triangle AIK must be similar to triangle BYP. And now what does that give us? Well, it gives us a bunch of little things. One thing that it gives us is that the angle BYP is the same as BYP is equal to the angle AIK. And now here, we're basically done with the problem because if AIK is BYP, similarly on the other side, we can get that CXP is equal to the angle AIL. And now the sum of LIK is equal to PXY plus PYX, which is 180 minus xpy. And so we have proven that xpy plus lik is 180, and we're done. Now this is one order of reasoning. And this measures out the problem, the solution is clean. There's another solution, another way to think about this. And that is to say, okay, what points like k and l, how does lik? I have introduced 2 extra points here. Instead of having 2 points, let me try to do this with 1 point. How can I get rid of lik? And the answer is, well, these are midpoints. So I can multiply ai, get a point here, call this point t, such that I is the midpoint of at. Now lik is btc. And I have used up everything now about this li and k. Now I can try to do that btc plus xpy is equal to 180. Now here I invite you to pause here for another minute and try to think about now this problem. So what do we have? We have, again, I'm going to draw a circle. I'm going to draw a circumcenter, A, B, C. And now I'm not even going to bother with drawing the in circle at this point, at least. But I have this I, and now I have T. Such that this here, right here, is the midpoint. So what do we have now? And now I have here Y, and I will have the other point on the other side. And I have P here. So let's see what this gives us. This is sort of a midpoint. We have reflected everything. Can we say anything about Ty? And when I draw a diagram, it looks pretty damn parallel to AB, which is interesting. Now the question is, can we actually prove that such a thing is true? Can we get an angle with YT? That seems difficult. But if this was parallel, we'd get this is alpha half. This is alpha half. We get a angle of, we'll get these are concyclic. That would just be very nice. It's something that could happen. It looks like that from our diagram, but the question is that actually true? And now let's think about what we just did. We reflected A, which had the in circle, with respect to the center of the circle. And now, what's it called? We are, now what is true? So you have a circle, think about this way. You have a circle with some center, you have a point, and you reflect it with respect to that center. And you draw 2 tangents here, and now you draw 2 tangents here. Right, because if Ty is tangent to the in circle, if this is in case true. What can you say about this quad, so to speak? And right here, pause for a minute and think about this. And the answer to that question is, well, let's actually and prove this. So a circle, I have a line, I have a point here, and I have this angle is x, this angle is x, and I have this point right here such that it's equidistant, such that now this whole thing, when I take 90-degree angles, I have this is equal to this, and I have this is equal to this. Ergo, by the Pythagorean theorem, this is equal to this. In other words, these 2 triangles are congruent. In other words, this is x and this is x. So now, if I take from T the, what's it called? If I take these 2 tangents, T to the in circle, they are going to have the same angle here, alpha half. Okay, so now we know this definitely needs to be true. Now, why is this actually alpha half? Because we also know that these tangents, this is x, x, these will create a rhombus, a parallelogram and a rhombus in particular. So now we know because of that we can sort of redefine y to get y prime and then figure out, okay, ty prime is parallel to AB and tangent to the incircle, so y prime is equal to y. Now we know this is alpha half, and we know that these 4 points are concyclic. Now similarly, once we get x, on the other hand here, we get txy, again alpha half, and we have that these are concyclic. And now what do we have? We have the angle ypt is equal to the angle yct, and we have the angle xpt is equal to the angle xbt, and so the angles in the triangle BTC sum up to 180, and then we also get that the angles, this angle plus this whole angle is 180, but this angle plus this angle is equal to xpy, and that solves the problem. Let me know if you have any other solutions, and as always, thanks for problem solving.